Hello everyone, welcome to this video tutorial. One guy asked me about linking all the Excel software to the ANSYS Maxwell, and I decided to record this video. I hope you find this video useful in your projects. So let's open one Excel file. So from here, Microsoft Excel worksheet. I generate a new worksheet here on my desktop and open this worksheet. Right. So first of all, here, as you can see, the extension of this worksheet is .xlsx. So in the first step, we need to change the extension, and we should use a macro enabled version. So from here, file, save as. I save the worksheet, the workbook in this format. As you can see here, Excel macro enabled workbook, right? So the extension is different, and I changed the name, test, save. So let's close, and here is the new Excel file that we have. As you can see, the icon is also different, right? The icon and what is the extension is .xlsm. So this is the macro enabled version, and we should use this version. So let's try a simple function. In the Excel, we can use the built-in functions of the software. For example, if I write here 5, I can use this function, sine function. This is a built-in function in Excel, and calculate the sine of this number. But how we can implement our functions in the Excel? For example, I want to write a function to sum up these two numbers, right? I want to write my function, for example, my sum, and this function has two inputs, right? And returns the summation. So how we can do that? From here, developer tab, we can open the macros, and if you don't have this developer tab in your workbook, from here, file, options, customize ribbon, you can activate the developer tab. Sometimes this is deactivated by default and you don't see the developer tab here. You should activate the developer tab, and then you can click on macros, click on the Visual Basic, and here we have the Visual Basic application, and we can write macros. So here is the sheet 1. We can write macros here, or simply we can insert our modules and use the code that we write in these modules. So this is module 1, and I want to write my code. The programming, the macro programming that is in Excel is the same as the macro programming that is in ANSYS Maxwell software, scripts, add definition. So here also we have a scripting environment, and we can write the code. The programming is the same, and this is good if you want to do optimizations using these two softwares. So let's write the function. I write sub or subroutine, my summation it has two inputs, x and y. So by default, the editor adds this line and subroutine. I delete the option explicit keyword here. You can search about that. This is used when you want to force the type of each variable in the code, right? So I use generic type. I know that these are integers, but if you place this keyword here, you should specify the type of each variable in code. So I delete that keyword, and this is the function name. The function name in the VBS language returns the output of the function. So this is x plus y. So save, yes. And now we can use our function in the Excel. So I write here my summation, this and this. And yes, so let's check. Excuse me, this is the function and function. Subroutine doesn't return any value. So save, and now let's use this function. My sum now is available, this input and this input. Yes, so we added our function here. Okay, now suppose I want to call this function by placing a button. So to assign a macro to that, I can write this subroutine, my macro, save. Here you can see my macro. So the function returns a value, but macro doesn't return a value. How we can run this macro and do the same thing that we have here? So we can do it by several ways. One useful way is to assign global names to the variables that we have in our design. Okay, for example, I define a name and I assign a unique name to this Excel cell. I write global variable x and assign a name here, global variable y. Yes. So here you can see the unique name of these two cells. And define name, global variable z, for example, the output of this summation. Now, let's go to the macro, my macro or my macro summation. I write dim x as double. Definition is different. This is declaration of a variable, and the type of the variable is double. And dim y as double. Finally, dim z as double. X is equal range. We use the range function. Input of the range function is a string that we assigned to the cell, the name, the global variable name that we used. So I return the value of that cell. So this is x, this is y. Finally, the z value is equal to actually this value, is equal to x plus y. Save. Yes. Now let's use the macro. Change this equal to 6. And let's delete this function, my summation. I use my summation here, right? So this the name of this cell is global variable z5. So when I press enter, this function run automatically, but to update this number, I have to press this button, right? So subroutine is good because sometimes you don't need to input everything inside this function, too many inputs, right? You write your macro and declare your variable, pick up the value of cells that you need, do the calculation, and override this value. Even you can automate that and call this macro by pressing the enter, right? That is not needed for our purpose. So how we can use this workflow to connect the Excel to the ANSYS Maxwell? Suppose we have this design. We have a C core, and this is also iron, and we have one coil here. And suppose we do analytic calculations to design this structure. We have this is the width of the yoke. That is the same for all of these dimensions. And this is the width of window. And this is the width of the coil. Also, this is the width of the window, and this is the gap. So I define these variables here, width of the window, width of the yoke, gap, and width of the coil. And here I write this number, for example 10, and I can write the unit in the next cell, 10 centimeter. Sometimes we can write millimeter, right? Also, we have the y yoke, width of the yoke. I write 3. Gap equal to 2 millimeter centimeter, and I want to create the model. So first we should record the macro, generate the macro in ANSYS Maxwell and record it. So in this project, tools, record a script to file, desktop, Visual Basic script, and I write my test, save, insert a new design, and generate this rectangle. This is we should define global variables, and then use those global variables or local variables to set dimensions of the model. So I define local variables, design properties, add width of the window 10 centimeter, yes, width of the yoke 3 centimeter, yes, and air gap 2 millimeters, yes. Now I can set the X size the x size of this rectangle is the width of window plus width of the yoke. Y size is 2 times width of the yoke plus width of the window. So I generate another rectangle. This is the position is width of the yoke and width of the yoke here. The x size is width of the window, y size width of the window. Yes. This rectangle, this one, subtract. Yes. And we can also draw this rectangle, the coordinates. This is the width of the yoke plus width of the window plus gap. Width of the yoke 2 times width of the yoke plus width of the window. Yes. So we generated this structure and stop script recording. Now let's check this generated macro. Edit. This macro is generated by software. So I can copy this macro and write a new subroutine here. I write generate FEA model. This is a subroutine for generation of the FEA model, and paste the code. So in these lines we declare object variables. Let's modify project set active project. Here we should know the name, but I changed this to this function, get active project. Generate the model in the active project that is open in the software. This is the active project. So if I delete this project and generate a new active project, even change the name, project 333, even I can access to this active project because this project is open and already active. Then we insert a new design and get the active design and set the active editor. So this function is for creation of the rectangle. This function is for definition of the global variables, right? Here, as you can see, this is for definition of the global variables. Change property, and we have this array. This is for definition of the width of the window, right? New props, width of the window, width of the yoke, gap, and right. So I delete these lines, yes, to avoid any confusion. And as you can see here, this is just for definition of width of the window, its value and its unit, right? So I cut the rest of the code, paste, and want to check my code step by step. Save. Yes. We can write a comment also. Define right main objects. The O stands for object, and here is declaration of variables I have width of window as double. This is declaration. Then we should have access to the width of the window. So define the name, global variable width of the window, global variable width of the hook, and also global variable gap. Yes, I defined three global variables. So now I can write width of the window is equal the same function that we had here, width of the window. So width of the window now is a double variable, but as you can see here, ANSYS Maxwell gets a string to define a local variable. This is 10 centimeters. So I can write width of the window, its string version is actually convert to str. We need its double version during our code to do the mathematics calculations, and here we need the string version plus what? Plus the unit. Its unit is in the next cell, so I can use this function, offset function, 0 and 1 column dot value, right? So this returns the value of this cell, 1 column offset. And now I can use this line to call this function. Let's save and try the code. So I place another button, generate FEA model, edit text, generate FEA model. So move here. If I press on this button, let's check. As you can see, this design is added and this variable is defined, right? So we implement our analytic calculations in Excel and pick up this value, change the string version, and write this macro, and yes, define the variables that we need. So we can do the same. This is width of the hook, air gap. So the same logic I can implement. Width of the hook, gap, and also we can have the string versions. This is good because when you design a motor and don't want to repeat the same things, you can generate your own templates. Excel is good. Even you can implement good optimization methods and store data, work with tables, lookup tables. Personally, I use it, so it's good if you try linking of the Excel to the ANSYS Maxwell. So yes, we can copy and paste these lines. So this is for definition of width of the hook, and this is for definition of the gap. Save. Yes. Now let's try again. Generate FEA model. So we have one error. Debug. The error is the name, the name of the design. Already we have this design name, so I delete and try the code again. Save. Yes. Save. Okay. Now this design is generated and we have these three variables defined. You can see the unit and the value, right? So now let's add the rest of the code, right? We don't need to edit anything. So copy and paste. Save. Yes. So let's try again. Save. Generate the FEA model. We have one error here. What is the error? What do you think? Let's check. This rectangle is generated. These lines are for definition of the, yes, we have double definition, right? I should delete this. Here we generate this rectangle, change property, again generate this rectangle and subtract. So save and delete this design and save. So now let's try generate FEA model. Yes. Now, as you can see here, this model is generated. And yes, we have, what is the value of air gap is 0. What is the reason? Here is 2 millimeter. 2. No, this is gap. Yes. Save. So this function is for generation of the FEA model, but after generation of the FEA model, we don't need to generate models, extra models, right? After generation of the model, just we need to update these numbers. We update our design, we change our assumptions, and just we need to update the model, right? We don't need to generate the model from scratch. How we can do that? We can add another macro here, subroutine of update FEA model. So we should do the same. Get the value of these variables and check how we can update the numbers. Record a script to file, my test. I change this number to 13. Stop. This is my test. And this is the function that we need. Change property. Yes. These lines are the same. Just we don't need to insert a new design, right? Just get active project and get active design. Yes. So change the value of variables. This is width of the window. We want to update this. And also we want to update width of the hook and gap. Save. Yes. So press another button, update FEA model. So this is for updating the model. So I write 8, 2, and 5 and want to update the existing model, right? This model is updated now. We saw the window. So 5, 3, 2, 8. So let's check. This is width of the window, width of the uke, gap, global variable, gap. This is the local variable, width of the uke, and this is the gap. Yes. We should edit these functions, these inputs, correct to get the correct result. So now let's test, right? It is updated. If I change the air gap value to 2, update the model, yes. So, we can add the rest of the components, right? Even add analysis, set up boundary conditions, and change these variables. For example, air gap, change the number, do the magnetostatic simulations, return results from the ANSYS Maxwell to Excel, store the results in Excel, and post-process the data. So the workflow is pretty the same, right? I don't think to explain and extend the time of this video. So this is what you need to call the ANSYS Maxwell from Excel, generate a new finite element model, update the variables. You can run simulations and return results, implement your optimization methods in Excel, and store the data. Okay, I hope you find this video useful. Thanks for watching.